For the last decade, deep space exploration has moved at a deliberate, methodical pace. The strategy centered on massive, multi-billion-dollar chemical rockets like the Space Launch System, designed to slowly build stepping stones in lunar orbit. That timeline is now colliding with a hard geopolitical deadline. China has mandated that its taikonauts will walk on the moon by 2030, putting America's long-standing lead in space at risk of being eclipsed. In response, a December 2025 executive order from the White House mandated a total overhaul of American space strategy, prioritizing immediate space superiority and forcing an aggressively accelerated launch schedule. A slow, risk-averse orbital strategy cannot compete with a rival nation sprinting for the surface. To win this new space race, NASA has to rewrite its playbook or concede the high ground entirely. In March 2026, newly confirmed Administrator Jared Isaacman announced Ignition, a sweeping overhaul that scrapped the existing Artemis timeline. The first casualty of this pivot was the Lunar Gateway. NASA abruptly paused construction on the multi-billion-dollar space station, which had been planned as a safe harbor in lunar orbit. This cancellation sent a shockwave through the international community. Partners like the European Space Agency, led by Director General Josef Aschbacher, had already spent years committing hardware and funding to the Gateway project. By stripping away the safety net of an orbiting station, NASA is forcing an all-in gamble. Every dollar and every piece of hardware is now being redirected towards establishing high-risk infrastructure directly on the lunar dirt. Phase 1 of the new Ignition plan bypasses orbit entirely, delivering new hardware, pressurized human habitats, and robotic rovers straight to the moon's south pole. To build a permanent base, the volume of logistics must scale up massively. NASA's new mandate requires launching 30 commercial robotic landers in just 3 years to ferry thousands of kilograms of cargo. Establishing a continuous presence introduces a severe bottleneck, the lunar night. Solar panels cannot keep a base operational through 2 weeks of freezing darkness, so the agency is pivoting to fission surface power, small nuclear reactors placed on the moon. The harsh conditions of the lunar base will serve as a proving ground for this nuclear hardware, but the true test of atomic spaceflight is happening simultaneously right now on a ship bound for another planet. The centerpiece of the Ignition plan is Space Reactor 1 Freedom. Mandated to launch by December 2028, it will be the first fully operational nuclear-powered spacecraft sent to Mars. This schematic illustrates nuclear electric propulsion. Instead of burning liquid fuel, an onboard fission reactor splits uranium atoms to generate intense heat. That heat is converted into an electrical current, which drives highly efficient ion thrusters. Compared to legacy chemical rockets, nuclear electric propulsion solves 2 problems at once. It drastically cuts the transit time to Mars, while generating enough power to push a much heavier payload across the solar system. A nuclear engine provides the muscle required to haul heavy, autonomous equipment across deep space. It is the prerequisite for delivering the infrastructure needed to prepare distant planets for human arrival. For decades, landing on Mars meant enduring the 7 minutes of terror, a complex sequence where a rocket-powered sky crane lowered a single multi-billion-dollar rover on cables. SR-1 Freedom replaces that risky procedure with a high-efficiency tactic dubbed the Skyfall maneuver. Instead of lowering a rover, the entry capsule splits apart mid-descent, releasing a swarm of 6 autonomous drones to fly themselves down to the dirt. These helicopters will operate as a distributed network. Equipped with ground-penetrating radar, they will fan out to scout for subsurface water ice autonomously. A drone swarm can cover more ground in a few weeks than a rover could in a decade. By rapidly certifying a resource-rich landing zone, this fleet turns a hazardous frontier into a prepared site for the first human crews. Meeting the strict 2028 launch deadline for SR-1 Freedom requires an immediate mobilization of resources back on Earth. Because this is a Pathfinder mission, NASA is forcing the activation of a brand new industrial base. Manufacturing facilities must be built and uranium supply chains secured to mass-produce nuclear hardware for spaceflight. Alongside the physical hardware, the agency must draft the legal framework required to safely launch active fission reactors from American soil on a regular basis. The 2028 Mars mission is designed to return data,
But its most lasting impact will be the activation of a domestic nuclear supply chain and the legal framework for regular deep space launches. For the last 50 years, deep space exploration relied on isolated, one-off scientific missions. NASA is now building a continuous, interconnected ecosystem of hardware. This transition starts close to home. NASA is preparing to hand the aging International Space Station over entirely to private industry, freeing up its budget to focus exclusively on the Moon and Mars. By offloading low Earth orbit to commercial partners, building a nuclear-powered base on the Moon, and deploying drone swarms to map Mars, NASA is linking 3 separate domains into a single logistics network.
The ignition plan replaces the era of the robotic visitor with a permanent logistics chain, stretching from low Earth orbit to the surface of Mars.